This video is a review of how to isolate for the unknown variable. First, a little background, so we're all talking about using the same words to describe the same parts of math. In math, the word term is used to describe everything that's separated by pluses, minuses, and equal signs. For example, in this equation, how many terms are there? There are 4 terms in this equation, all separated by equal signs, plus and minus. 1, 2, 3, 4. In this equation, how many terms are there? 5. 1, 2, 3, 4, 5. In this equation, how many terms are there? 4. 1, 2, 3, 4. 4 different terms, all separated by plus, minus, or an equal sign. When I use the word expression, what I'm talking about is the sides of the equal sign. So there's an expression on the left and an expression on the right. So in this example, in this equation that I have right here, I have 2 expressions, everything on the left and everything on the right. In this example, 2 expressions, everything on the left and everything on the right. Opposite functions. Opposites, sometimes referred to as inverses, kind of depends on what we're talking about here. But we'll think of it as opposites. So opposite functions, I have addition, and the opposite of addition is subtraction. Multiplication, the opposite of multiplication is division. And then finally, the other one we're going to be using is if I have something that's squared, I'm looking for the opposite of squared, and that's going to be a square root. So these are opposites. And a final piece to keep in mind is because we're talking about an equation that has an equal sign on it, whatever math I decide to do on one side of the equal sign, I've got to do the same math on the other because that's what the equal sign means. It means equal. So I've got to do the same thing to both sides so I really don't change the equation itself. All right, so let's talk about how to use this. So our goal is to simplify or isolate the unknown. So what I want is I want an expression where I have the equation all by itself on one side of the equal sign and everything else on the other. So to do that, when I'm given an equation, the first thing I'm going to do is I'm going to simplify by combining like terms on each side of the equal sign, if possible. And really, you could do this anytime. You can do it multiple times as you're isolating the variable. So it doesn't have to be the first step, but in this equation, it does look like I can do it at the first step. So look at the left side. Do you see common terms or terms that are the same? I do. I see 3 and I see -7. And then I see 4t is one term and 6t. So I can combine the 3 and the t because they're like terms, and I can do 4t and 6t because they're like terms. So you can see how the variable helps us to separate out the numbers and the terms. If I had something like t squared and t squared, those would be like terms as well. So the 3 and the -7, that adds up to -4, and the 4t and the 6t, that adds up to 10t. So that's what I mean by combining like terms. Now at this point, I'm going to move the equation, or isolate out the variable, and I can put the variable on the left side or the right side of the equal sign. I'm going to choose the left side. It really doesn't matter, but since eventually I'm going to say t equals something, I'll just go ahead and go with that. To do that, what I'm going to do is I'm going to move every term without a variable to one side and every term with a variable to the other side. So I'm going to do this one step at a time. And that's really important because when you go back and look at your work later on, if you've combined multiple steps, it's hard to figure out if you don't know what you're doing or if it's a math mistake. As someone who's going to evaluate your work, it's also harder for me to figure out, is it just a simple math mistake, which isn't a big deal, or am I looking at something where you really got lost and just kind of made things up? So you need to show every step to support your work. So here's the equation as it stands now. -4t plus 10t equals 3t plus 31. So I'm going to start by moving some variables around. I'm going to move everything with the t on the left-hand side, like I said earlier. So I'm going to take that positive 3t and do the opposite. I'm going to subtract 3t from both sides. So it's going to look like this, -3t plus -4. And then on the right-hand side, -3t. So now I'm going to combine the like terms again. That's going to be everything with a t in it on the left-hand side. On the right-hand side, it's really nice because 3t minus 3t, that goes away. So that's gone. So all I have is 3t minus 4t equal, that gives you 7t. Next step, I need to move the -4 because everything with a t on the left, everything without a t, I'm going to push to the right side of the equal sign. So it's -4. I'm going to do the opposite. I'm going to add 4. So I'm going to add 4 to both sides. You can see on the left side, 4 minus 4 is 0, so that's going to go away. On the right side, I've got 31 plus 4, and those are like terms because they don't have a variable after them. They're just the number by themselves. So that's going to give me 35 on the right. So now I have 7t equals 35. So I'm still trying to isolate t. So to isolate t, if I could just divide by 7, and I can, I'll divide both sides by 7. So I'll divide the 7t by 7 and the 35 by 7. You can see how the 7's divide out, leaving me with t is equal to 35. Or, sorry, equal to 5. So that's my final answer.